Hello. So in this class, we'll do Algebra 2, Chapter 6.3, Logarithmic and Logarithmic functions. So we know like 2 raised to power 2 is 4 and 2 raised to power 3 is 8. Now, what power of 2 will give us 6? So we cannot know exactly algebraically. So what we can use is we can use logs for this, and the answer would be. So here is where log is used, and we say it as log, the log base 2 of 6, or we can say the base 2 log of 6. So if a raised to power x is equal to given as y, this is an exponential form, and if we have to change it into log form, it will be log base a of y is equal to x. So y here would be argument, a would be base, and x here is the output. We could have done like a raised to power y is equal to x, then it would be different. But this is like if x is here, this is the output x. So argument here, it must be greater than 0. So we see that argument must be greater than 0. Base should be greater than 0 but not equal to 1. And output can be positive, negative, or 0. So a base should always be positive, because if it is raised to a fraction number like a raised to power half, and if it is a negative, it will give imaginary or undefined answers in regular math. So it should be always greater than 0. And argument must also be greater than 0, because, for example, suppose if we have log 10 and if the argument suppose is negative 5, and this means x. So if we convert it into exponential, no value of x would give it 10 raised to power of no value of x would give it negative 5. No real number power of x can turn positive base to a negative result. So this is not possible. That's why argument and base both should be equal to 0. This is not an equal to sign. I just wanted to show it. Okay. So common logarithm has base 10. Okay. So it is written as like this. But if no base is given in its position here, when the base where the base has to be written, it is assumed that base is 10. And natural logarithm, in the last class we studied about e. So that is basically base is e. So if we write ln x, so ln means the base is e. So natural logarithm has base of e, and common logarithm has base of. Now this is question 9 and we have to write it in exponential form. So we see that this is base. We know that a of x y, if it is like this, then log a comes here, y is equal to x. Okay, so 8 is base is half, y here is negative 4, and this is equal to 16. So this is the exponential form of the log which is given here. Let's do one more of this. So in this base is 3. So we write base as 3 and output is -1. Okay. And this is given as, and the argument was 1/3. So this is the exponential form of the log function given. So now we have to write this in form of logarithmic function. So we can see from here also, here. So this is A. So first we write log, then we write base A, which is 125. Then this is the argument. So we write it 25, and this is the out. Okay. So we say this as log of the log base 125 of 25. Okay. Let's do one more of this type. So this is 49 raised to power half is 7, and we have to write the log for this. So log, this 49 is the base, so we write here. This 7 is the argument and half is the output. So we say this as log base 49 of 7 is half. Let's do another problem. So this is another question and we have to evaluate it. So, and we'll be using this power rule and exponent rule. So let's first start with this simplifying. So this is log base 5 of 1 over 625. So 1 over 625 we can write as 5 raised to power 4. Okay. And if we use this exponent rule, it will be log base 5 of 5 raised to power -4. Okay. Now, if we use the power rule, we bring the exponent in here. Okay. So this was -4. Okay. So this will become -4 log base 5 of 5. So another thing we know is a raised to power 1 is a. So if we write a log of this, we will write like in log form, it will be log a, base will be here, argument will be, this would be the argument, and this will be the output. So any number we can put here a, which is definitely greater than 0 and not 1. So this will give us 1. So this is equal to 1. So -4 times 1 is -4. So -4 is our answer. Let's do one more problem of same type. So now in this we have to use the same power rule which was given here and the exponent rule. So 512 we know it is equal to 8 raised to power 3. We are trying to match with the base. But we can also write it in form of base 2. But because here it was 8, we'll write this. So this will give us 1 over 8 raised to power 3. Now we'll use this exponent rule and it will give us log a base 8 of 8 raised to power minus 3. Now we will use power rule, which was here, and the exponent comes and gets multiplied to the log. So we will write log 8 log base 8 of 8, which gives, we know here it was is equal to 1. So this is negative 3 times 1, which is negative 3. So negative 3 is the answer. So now we'll use the inverse properties. So we know we have, suppose I have a function g of x, which is log base b of x, and we have another exponential function, which is b raised to power x. And we know that these both are inverse of each other. Okay. So when the function is inverse of each other, then we know that function of a function is equal to x. Okay, we learned this in composite function that when the two functions are inverse of each other, then function of a function is x. So let's use that. So this is g. G is log b of x. But here x is given as fx. So let's put the value of fx. So now we put the value of fx, bx, and we simplify and we get each other. So exponential functions and logarithmic functions, they undo each other. Basically, they both are inverse of each other, and when we find the function of function, it is equal to x. So if we write in this form, it will give us x. Okay. Now let's do f of g of x. So this is f of g of x. F of x is b and g of x was given as the input. Then we put g of x here. And this, because they both are inverse of each other, this is equal to x. So we'll use these properties while doing the next problems. Let's do. So we have to simplify this. We see that this is in this form. Okay, so this will be equal to x. We can do it in another way also, like let us put log of 7x is equal to a. So if this is equal to a, then 7 raised to power a is x. Now if we substitute the value of a, which was log 7x, then we get x. So we can directly get x by using the inverse properties, or we can let log of base 7 log base 7 of x is equal to a, then 7 raised to power a, and the question is equal to x if we convert this. Okay, and then substitute the value of a x, we get substitute the value of a and we get it x. So this is equal to x. Let's do another problem. So in this form, again, we see that this is in this form. E is same as B. It is the same base. Ln has the same base as log of E is same as ln E. They have the same base. So the answer would be 4. We can do it in another way also. that let ln 4 be a. So this will become e raised to power So we get e raised to power a as 4 if we convert because the ln has base e. And now if we substitute back the value of a, which was ln 4, we get ln e ln 4 is equal to 4, which is equal to 4 here. So now if we have to do this question, we can see how we can use the inverse properties and how we used here. This was equal to x log base b of b raised to power x was equal to x. So we can write here instead of x, we have 2x. So this will be equal to 2x using the inverse properties. So we can also do like this. We let 3 raised to power 2x is equal to a. So now if we convert this into log, base is 3, argument is a, and this is equal to 2x. Now substituting back the value of a, we get this, which was our question, and 2x is the answer. So we have to find the inverse of this. So we know how first step we change x to y and y to x. And then we write the equation in terms of y. Okay, so this is x. We change y to x and here we change x to y. Now we can change this. So the base is 1/5, which will be the base of exponent, and x would be the exponent, and the output would be y. So the inverse of this function is this. Okay. Let's do one more problem. So we have to find the inverse of this. So first let's change y to x and x to y. And because we have to write the equation of y on the left and everything else on the right, basically y in terms of x, let's take 9 on the left side. So this becomes 5 raised to power y is equal to x plus 9. Okay. So now this is, now we have to convert this in log form because we want the y. So we will write, this will be log, base will be 5, okay, and argument will be x plus 9, and output is y. So this is inverse of y is equal to 5 raised to power x minus 9. So we have to see, we have to graph this function, log function. So what we'll do to make it easier, first we'll find its inverse. So inverse, we know it will be, so we interchanged x and y here and then we simplified, and this is the inverse. So now we have got the inverse, so it will be easier to graph. Let's make a table of values. So we have formed a table with x values, 5x values, and we got y values for this. So now we know that these are the values of inverse. So we will interchange, we'll reverse the coordinates for the points of y is equal to 2x plus 1. So we will reverse the coordinates and now then graph it. Then it will be the graph of the log function given here. So when we have reversed the coordinates, we are getting the x. We'll put these y1s as x and y will be the y of this function, the original function. So let's graph. So we plotted the points like this is half, this is -2 here, this is 1 minus 1 here, 2 when x is 2, y is 0, when x is 4, y is 1, and when x is 8, it is 2. So we can see that this is the graph of our original function. So we first found the inverse, then we found the value of x and y, then we interchanged the values here and graphed. So please keep practicing and please let me know if you have any difficulty. And thanks for joining. Please do all the questions from the exercise. Thank you.